graphs. So let's move. Types of graph used in economics. In economics, we use graphs to show 4 broad types of relationships. The variables that move in the same direction and the variables that move in opposite directions. And also variables that have a maximum or minimum points, as well as variables that are not related to each other. So in economics, we have what is known as positive relationship. When you talk about positive relationship, it occurs when 2 variables move in the same direction. So if one increases, the other also increases. This is shown by a line that slopes upward from left to right. So when you talk about positive relationship, you are talking about a relationship that exists when 2 variables move in the same direction. So the relationship is shown by a line that slopes upward from left to right. An example of such relationship in economics, you can see from price and quantity supplied, income and consumption in many cases. The 3 types of upward sloping lines for positive relationship, we have the positive constant slopes, the positive increasing slope. This is a positive constant slope. I'm saying that with a positive relationship, if one variable increases, the other also increases. But if the slope or if the increases is constant, it means you have a positive constant slope relationship. And if the slope, the slope is what? Increasing, you have positive increasing slope. And if the slope is at a decreasing rate, you have a positive decreasing slope. So this is when you see a graph with this kind of slope, it means you have a constant slope. Then a slope that is increasing, a relationship that is having an increasing slope, we term it as a positive increasing slope. And a relationship that has a decreasing slope, you can also term as what? A positive decreasing slope. They also have a negative relationship. Am I moving fast?
Yes, sir.
Yes, sir. Yes, sir.
Okay. I'm saying that we have types of graphs used in economics. When the factors are moving in the same direction. And also when we see variables that move in opposite direction. And also when we see variables or factors that have a maximum or minimum points. Then also variables that are not related. So economics, we use this graph to determine these kind of directions. So the first direction is the positive relationship. So in economics, when we see positive relationship, we are saying that it exists when 2 variables move in the same direction. That is, if one increases, the other also increases. So this relationship is shown by a line that slopes upward from left to right. An example of such relationship is price and quantity supplied. So when price increases, quantity supplied also increases. Income and consumption. When your disposable income increases, your consumption level also increases. So it has a positive slope relationship. The same thing applies to price and quantity supplied. When prices increases, quantity supplied also increase. So it has an upward slope that from left to right. With the positive relationship, we have 3 main upward sloping lines. So when the slope is constant, we say that we have a positive constant slope. And when the slope is at an increasing rate, we say that we have a positive increasing slope. And so when the slope is at a decreasing rate, you say that we have a positive decreasing slope. Then we move to the negative relationship. Negative relationship also exists when two variables move in the opposite direction. Thus, if one variable increases, the other decreases. This is shown by a downward slope that from left to right. The common examples in economics is price and quantity demanded. When price of goods fall, the quantity demanded rises because consumers are what? Rational. And also unemployment and output. When there's more unemployment in the economy, productivity or output also reduces in some contexts, in some cases. And the negative relationship, we also have three main slopes. You have the negative constant slope. That is where the slope is what? It's at a constant rate. When one variable increases, the other falls. When the slope, the differences between the y-axis and the x-axis, when the differences are constant, you say that it has a negative constant slope. When the differences between the y-axis and the x-axis is at a decreasing rate, then you term it as a negative decreasing slope. And also when it's at an increasing rate, you say that the graph or the relationship is what? At a decreasing rate, or is at a decreasing what? Slope. So these are the main three graphs and the negative relationship in economics. So just know how the curves behaves.
So
also in economics, yeah, hello.
Yeah, so there's a answer. There's a new one to ask.
Are there?
So it's Ni want to ask a question.
Yeah, Ni.
Good morning, sir.
Yeah, good morning.
All right. So when you were talking about the positive relationship, I think you got to a point whereby you were saying that, so when the price decreases and then quantity also, when price increases and quantity increases, we can say there is a positive relationship. I want to ask that, is this based on certain situations, or that is the general principle? Because the principle, as I know, is that ideally, since we are rational beings, when price increases, quantity decreases, and when price decreases, quantity demands increases, and vice versa with the supply, law of supply. So I want to know, are you saying this that is based on certain situations, so that, you know, sir, there are times that price may increase and yet quantity demanded may also increase? Thank you. That's my question.
Okay. In economics, we always have an assumption or an axiom that all other things being equal, when all other things are equal, when prices increases, quantity supplied also increase, because producers or firms are rational. They always aim at maximizing profit. So when they see that prices are increasing, they will increase their quantity supplied, when all other things are constant. The same thing applies to consumers. When prices of goods falls, the quantity demanded for that goods also what? Rises. Right now, when we said there's a fall in the price of mobile phones, iPhones, we see the number of consumers, the number of people rushing to buy what? Mobile phones. Typical example is when there's a promotional sales. For instance, assuming LG is doing promotion, Hisense is doing promotion. You can see the number of consumers rushing into their shops to buy their product because prices has fallen. They've reduced their prices. So in economics, we have an axiom that when all other things are constant, when prices rises, quantity supplied also rises. So that means that we have a positive relationship between prices and quantity supplied. The same thing applies to income of the consumer. If your income rises, the kind of ladies you'll be chasing it will be different because now your disposable income has increased. If your income rises, now you'll be no more eating gari and beans. You'll be rather moving to what? Restaurant to buy expensive food. So when such relationship exists, we are saying that we have an upward slope or we have a positive relationship because consumers are rational. They always aim at maximizing what? Satisfaction. So with a negative relationship as well, since consumers are rational, when there's a fall in price, the quantity demanded of that product also what? Increases because we all aim at maximizing what? Satisfaction. The same thing applies to unemployment and output. A country with high unemployment rate, their productivity, their output level is low in some context. Let's see Ghana. Ghana GDP, we don't have, if you compare GDP to US, you can never compare Ghana's GDP to US because unemployment rate in Ghana is very high. But compared to US, it's not like that. So when it comes to negative relationship, we are saying that when two variables move in the opposite direction, that is when prices rises, the quantity demanded falls. We are saying that such line or such a slope is a downward from left to right. Is that okay? Ni? Hello?
That's okay, sir, please.
Okay. Now, so in economics, we also have a minimum and a maximum graphs. Economics is about optimizing or doing the best with limited resources. That is, in economics, we often want to what? Achieve the best outcome. For instance, making the highest profit or achieving the lowest possible cost of production. So economists often study situations involving the maximum point and the minimum cost. Such relationships are represented by curves that have a turning point. So this is a maximum point. But in economics, we always aim at maximizing profit. So, and also minimizing what? Cost. So when the curve is upside down, we are saying that the curve is what? Is at a maximum point. Then you have the minimum point as well. So just appreciate how the curves behaves. When we talk about maximum graph or the minimum graph, you should be able to what? Appreciate it. Is this one clear?
Yes, sir.
Okay. Sure. Then we have the independent variables. Sometimes two variables are not related at all. In such cases, one variable does not respond to changes in the other. No matter what happens to the value of one variable, the other variable remains constant. The graphs below shows the independence between two variables. Sometimes two variables are unrelated. This means that no matter what happens to one variable, the other remains what? Constant. Therefore, you have the horizontal line, then the vertical line. So there's no relationship. That's the horizontal line. That is, no matter the price, the same quantity will be demanded. No matter the price, this is the vertical line. No matter the price, the same quantity will be demanded. This is the horizontal line. A slight change in quantity will affect demand. Can you give me an example? That at the same price, more or less quantity will be demanded. Give me an example of such product.
Sir, petroleum products.
Petroleum products. What about no matter the price, the same quantity will be demanded?
Yes, sir.
Okay, you just appreciate how the graph behaves. When you move to demand and supply, you know how it's applied in demand and supply. So just appreciate how those curves behave. When we say vertical line, when we say horizontal line, just appreciate it. So it will be applied in when we are dealing with demand and supply, consumer behavior, and other stuff. The concept of slope.
Yeah, hello, sir.
Yeah, Ni.
Yeah, so I wanted to say that some medical items, that no matter the price, the quantity demanded doesn't change. So that, for example, I mean, those having renal issues, kidney issues and things, there are some items you need them irrespective of whether the price is going up or not. You are forced to buy them, and because you have no other option.
Yes. So when we are dealing with demand and supply, we all appreciate those things but as it stands now, just appreciate how the graphs behaves, their nature. Just appreciate their nature. Okay. Concept of slope. When you talk about slope is just a straight line that shows how one variable changes as another variable changes. It tells us how one variable changes when another variable changes. It is measured or it is calculated as the ratio of the vertical change to the horizontal change between two variables. That is the change between the y-axis and the x-axis. That is y-axis 1 minus y-axis 2 minus y-axis 1 over x-axis 2 minus x-axis 1. So that's the change in y over the change in x will give you the slope. So the slope indicates the rate of change between the variables. It shows how much y changes when x changes by 1 unit. So for a straight line, the slope is constant. So this means that the relationship between variables does not vary across the graph. So we have a positive slope. When you divide the change in y-axis over the change in x-axis, when you get a positive figure, positive number, you say that you have a positive slope. So when you divide the changes in y-axis over that of the x-axis, and you get a negative figure, you say that you have a negative slope. Any questions so far?
Sir, please, can you go over again with this positive slope, please?
I'm saying that slope deals with a straight line where one variable changes as another variable what also changes. We measure the slope as the ratio of the vertical change to the horizontal change between 2 points. When you talk about the vertical change, you're talking about the y-axis to the change in what? The s-axis. That is, when there's a change in the vertical values, that's the y values, divided by a change in the horizontal values, that's the s values, then you get the slope. Therefore, the slope indicates the rate of change between two variables. It shows how much the y changes when x changes by 1 unit. So when the change is constant, you say that you have a what? A constant slope. Then you have a positive slope when you divide the y-axis, the changes in the y-axis over that of the x-axis, and you get a positive number. So with a coordinate, let's say we have a point 2 and 3. 2 is on the x-axis, then 3 is on the y-axis. Then 6 and 6. And what to determine what? The slope. It's a matter of subtracting the first s-axis, no, the second y-axis minus the first s-axis, the y-axis. They divide it by the second s-axis minus the first y-axis. So therefore, when you get 3 over 4, you are saying that you have a positive slope. But when after division, they will get negative figure. You are saying that you have a negative slope. So let's take the 2 points on the graph. On the 2 points, you have 6, 6, then 2, 3. Therefore, we compute the change in x. So assuming the points are when s increases from 2 to 6, y increases from 3 to 6. Therefore, for us to compute the change in x, we subtract the second x minus the first x. That's the 6 minus 2. So 6 minus 2 gives us 4. For when we want to get the change in y, we subtract the previous y coordinate minus the initial y coordinate. Therefore, we get 3. So we know that changes in y over changes in x gives us the slope. Therefore, 3 over 4 will give us the slope. Since we are getting positive figure, we say that the slope is a positive. Therefore, it shows that both variables increases together. But let's consider that of the negative slope. Assuming when x increases from 2 to 6, y falls from 6 to 3. So, in computing for the changes in x, we subtract the previous, Ima.
Hello, sir. Hello, sir.
Yes, sir.
So I want to find out in an exams, how is this question is going to be put? Because I'm confused here.
Just appreciate how you calculate the slopes. All these will be applied when we are dealing with demand and supply, consumer behavior, and other stuff. So all these are mathematical tools we use to apply in the economics. So just appreciate how they behave, how they are being calculated. So when we are applying them in the economics, you not find yourself wanting.
Okay, okay, all right, very well.
So assuming you have a demand diagram, and we are asking you to calculate for the slope of the demand curve. These are what you applied to calculate for that slope. So just appreciate how, when we say a positive slope, how the measures you use to calculate it. And when we say negative slope, how you be able to compute the negative slope. Ken?
Yes, sir. So, sir, technically speaking, per what you are demonstrating, it means that if I do my graph and I get my x-axis, which is horizontal, and I get my y-axis, and for instance, I want to calculate for demand or maybe the supply, and I have the coordinates. The coordinates are the points that are picked on the graph. So with the
Yes.
one, let's say for x, I have 6. First of all, I have 2. So I'll go on the x axis and then pick the point 2. And then I also pick the point 6, which is going up. So it means that 2, 3, 4, 5, 6. Then I mark. So if I want to calculate the change between the x and the y, so it means I'll pick the point 2 and the 6, meaning that I have to subtract the 2 from the 6 for the x. It will give me a figure which is the 4. And then I'll come to the y-axis and also pick 3, the 6, and then the 3. I'll get an answer. So say the x and the y, I'm seeing that it is 3 over 4. Technically meaning that 6 minus 2 over 6 minus 3. That is giving me the 4 over 3.
Yes. Yeah.
Okay.
So
Okay.
assuming this is our graph, at this point gives us a coordinate of 6, 6.
Okay.
6 for x, 6 for y.
Okay.
No, this is a for y, y. Then this is for x, x. So these are the coordinates. So these are the coordinates. So when we want to find out the differences, we subtract the first x.
So say the first x is the 2 and the 3.
Yes.
2 and 3. I pick those points on the x-axis.
I'm coming.
Right. Okay.
So assuming the points, so you just appreciate this line. We are saying that assuming x increases from 2 to 6, the first was 2, then increases to 6.
But we are picking all on the x-axis.
Wait.
Okay.
These are the coordinates. We combined 6 on the x-axis, then 6 on the y-axis. That's where we got this point.
Okay.
Then we combined 2 on the x-axis, then 2 on the y-axis. Then we got this point.
Okay.
2 on the x-axis, 3 on the y-axis. Then we got the coordinate of 2 and 3.
Right.
6 on the x-axis and 6 on the y-axis. Then we got this coordinate. That's
Right.
where we joined the two lines to get this graph.
Okay.
If we are saying that if you want to get the slope, now these are the coordinates for this point and the coordinate for the other point. The first value is x, and that of this one too is x. So we are saying that assuming x increases from 2 to 6, what is the difference? You subtract the 2 from 6. And assuming y increases to 6,
Right.
what is the difference? You subtract the 3 from 6. But we all know that slope is what? It's the change in y over the change in x.
Yes.
That is the change in y, which is the 6 minus 3, over the change in x, which is the 6 minus this 2.
Okay, 2.
Yeah. When you divide it, so change in y is 3, the change in x is 4. Therefore, this is how we got this number.
Oh, yes, sir. Yes, sir. Clear. Thank you, sir.
You're welcome. The same thing applies to... Okay.
A question, please. Okay, so I would like to find a bit of clarification. Would we be given these numbers to plot on the graph, the coordinates, or there is a mathematical function we would need to apply before arriving at the coordinates and then plotting them on the graph to arrive at the slope?
Okay. We will give you a demand, let's say prices and quantity demanded. And we will ask you to use it to draw a graph. Then after drawing the graph, they need to determine the slope. I hope I'm clear.
More than clear, sir.
So this, just know how to calculate the slope. So when we are applying it into, let's say, demand and supply, you'll be okay. Any question? Are there?
Hello, sir. Hello, sir. Can you hear me?
Yeah.
Yeah. So last week, some of us couldn't attend the in-person session for the lectures, and so there was some trial test you gave, some questions you gave us to try our hands on. I will come in later because I wanted a clarification on. I did it, but still it's not clear to me. So once you were about to finish, I will just chip in that, and then you just go over that for me because some of us couldn't attend, and it was that was when you did the calculations.
Okay. When it comes to, okay, let's finish with this.
Okay.
Then I want to try as much as possible whenever we are meeting face to face. All the calculation will be done over there.
Okay.
Okay. But you will try our best to. So any questions so far with the graphs and the slope? I hope each and everyone can calculate a slope of a graph.
Yes, sir.
Our next topic is equation of a line functions. Equation of a line. In economics analysis, we use equations to describe different kinds of relationships. There are 3 main types of equations that are commonly used in economics. You have definitional equations, behavioral equations, equilibrium conditions. Each serves a different purpose in economic analysis or in economic modeling. So when you talk of definitional equation, it expresses an identity. So definitional equation simply states what something is. What something is. So it states that 2 expressions mean the exactly the same thing. Typical example is profit. PAR is equal to total revenue minus total cost. So this is a definitional equation. it states what something is. So it is an expression that means exactly the same thing. That is profit equals total revenue minus total cost. There's no assumption here because you all know that when you want to get profit, it's a matter of subtracting the total cost from the total revenue. So there's nothing as behavioral assumption. You don't assume anything. So in such relation or in such equation, you say that it is what? A definitional equation. There's no assumption. There's no behavioral assumption. You don't assume anything. Then the next equation is behavioral equations. When you talk about behavioral equation, it describes how one variable responds to changes in another. It reflects the actual economic behavior. For example, consumption depends on income. Consumption function, C is a function of income. Consumption function, C is a function of income. C represents consumption function. Then Y is the income. When it comes to the cost function,
Someone is annotating.
that's your call. With a cost function, we are saying that cost is a function of quantity. So this equation explains how economic agents act under different conditions. So with this equation, there's behavioral function. There's an assumption. We are assuming that cost is a function of what? Quantity. What about the other factors affecting the cost? So in such equation, we are saying that there's some behavioral assumption attached to such equation. And also consumption function. Consumption is also a function of what? Income. Your consumption level depends on your income. So this is a function. So this equation explains how economic agents act under different conditions. Then we also have equilibrium condition. So equilibrium condition shows when a system is in balance. That is when the forces are balanced. It specifies the condition under which opposing forces are equal. That is when demand is equal to what? Supply. That is, there's equilibrium. That is demand, the function of demand is equal to that of order, the function of supply. Or when S is equal to 1, is also equilibrium condition. So these equations are used to determine outcomes such as market price or national income. So when we want to determine the market price of cocoa, we use the quantity supplied and the quantity demanded. The world market are saying that the production of cocoa are many. Therefore, the number of cocoa product that they are demanding is less as compared to the number we are supplying to the market. Therefore, when the demand and the supply equate, we say that there's what? Equilibrium condition. That is where the prices of cocoa was determined. Ghanaians were producing more. Cote d'Ivoire too were producing more. So in the world market, there are more productivity. What about the demand for the product? So whenever demand is equal to supply, therefore the prices of the goods are determined. So we are saying that these equations are used to determine outcomes such as market price or national income. Nani?
I would like to find out, in simple terms, if I can say that equilibrium is the point at which demand meets supply, or that would be too simplistic.
They are the same. When they are equal, when they meet. But in economics, we want you to be writing the terms. You can't write only English for us. You need to be writing the terms. So when we talk about profit in economics, you can't just write
Cost
revenue
price.
is equal to cost. But you should write total revenue is equal to total cost. Because in economics, we want the terminologies. It's very important in economics.
Certainly.
Any question?
Listen. Hello, sir.
Yeah, Michael.
Sir. I want to understand the equilibrium again. From your explanation with the example you made with the cocoa, you mentioned that um, when production of cocoa is more than the demand, that is where you mentioned that equilibrium difference. But right now, I heard one of my colleagues mention when demand meets supply. That is where equilibrium happens. But from your explanation, it looks like when there's less demand
Okay,
and
when you,
more supply.
yes. When there's what?
Because I want to when there's less demand but more supply. So
When
um
there's less demand.
yes, when the
No,
demand is less, but the supply is more.
no. When the price is less,
Okay.
producers supply less. When the price is high, consumers demand less. Or let's take it this way. When the price is high, consumers demand less. When the price is high, producers produce more because consumers maximizes what? Utility. They maximizes satisfaction. Producers maximizes profit. So whenever the prices are increasing, they want to produce more to get more profit. But the consumers, whenever the prices are increasing, they will demand less because they want to what? Maximize satisfaction. So prices are determined whenever the demand meets or the demand equates the supply. That is why the prices of goods and services are determined. And I said the typical example is when it comes to the world market of cocoa, the fall in price is as a result of what? The more productivity in the market. So when the consumers are not willing to demand more of our cocoa, what will happen? The price of it will fall. So if the prices are falling and you're also producing, then it will come to a condition that, therefore, if I give you 2,500 and you accept, if I give you 2,500 and you accept, therefore there's what? Equilibrium price. Typically, I got some information about 2 days ago that if you go to the various villages, though the prices are 2,500 for cocoa, but still, some are selling DS at 1,500 because so you have the production, you have the productivity, you have the cocoa, you have the product, but they are not willing to buy because they are saying that they don't have money to buy. So assuming a producer, a farmer, needs money urgently to send his or her ward to school. But the buyer is saying that, oh, I can give you 1,500. So if the buyer accepts that 1,500 and give the product to the buyer, that is where there's equilibrium. So whenever demand is equal to supply, there's equilibrium. So the equilibrium condition is when the system is in balance. I hope it's clear. Is that okay?
Crystal clear. Crystal clear.
Okay.
To me.
Any questions so far? Any questions so far under the equation?
Yes, sir.
Ken.
Sir, you mean to say that
Is that your actual name? Is that the correct name or just a Nikki?
sir, is my correct name?
Okay.
My correct name, please. So it means that when demand meets supply,
Yes.
equilibrium is created.
It's established. Yeah. So when the equilibrium, yes.
When demand meets supply, equilibrium is established. Okay.
We want it this way. We want it this way. When demand equates supply.
Okay. So,
when demand equates supply, equilibrium is established.
Yes, or you can say, just make it simple. When demand is equal to supply. When demand is equal to supply, there's equilibrium.
There's equilibrium. Thank you, sir.
At that equilibrium level is where you get the price and the quantity.
is there a situation where we can have the exact demand using the exact supply? Let's say the world market.
I can't get you.
Yes, just cite an example. Let's say in the world market, the demand may be 1,000 tons of cocoa, and then countries like Ghana, Cote d'Ivoire, and other countries were also able to produce the exact 1,000 tons of cocoa onto the international market. So
Okay.
in this case, is it different? Is this scenario different from the equilibrium, or this one has a different definition to it?
Okay. Like you are producing, and someone too is what? Demanding.
Yes, sir.
So, assuming you are producing more, and the person is also not willing to buy, and he gives you an offer that will give you this amount, and you accept. The moment you accept that amount, it means the equilibrium price has been established. There's balance.
Hello, sir.
Yeah.
Sir, please, the functions. Okay.
Just
sir,
take it down. Come, you come again.
Okay. Should I go ahead?
Yeah.
So I'm asking that the function of cost, consumption, do they follow the proportion and the proportion principles?
Just observe this. We are saying that when it comes to function, the consumption function, we are saying that the consumption function, consumption is a function of income. That is, other things can determine what consumption, but major determinant is what income.
Okay.
That's why we are saying that consumption is a function of income, but other things determines it.
Right.
So we are saying it's a behavior.
Okay, can change. Okay.
Yes.
Yes, sir. Thanks.
Our next topic is function. In economics, in economics, he also describes relationship between variable as what? As function. So function describes a consistent relationship between variables. So if each value of the variable produces a unique number of another, then one variable is a function of the other. So in a general form, when you see y is equal to, y is a function of x, or when you see, so this is a function. So a function describes a relationship between variable, the relationship y is equal to x is a function. Y is a function of x. So in economics, we normally write this y is a function of x. So this means that y depends on x according to a specific rule. Y depends on x. Y depends on x. So we have types of what? Functions. We have the linear function, then the quadratic function. With the linear function, we represent the linear function as a straight line relationship. So in a general form, I just want you to appreciate how, when we say function, it means. When we say linear function, it means. Though with the linear function, we are saying that it represents a straight line relationship. In the general form, when we see y is equal to mx plus c, we are saying that this is a linear function where m measures the slope. So on the linear function, m is the slope. The c is the intercept. Then the x is what? The variable. So we are saying that when y is a function of x, when you are writing it in the linear function form, you say y is equal to the slope of x, the slope of the line plus the intercept. So these variables will change. The x and the y can change, but the c and the m will not change. So this form is widely used in economics model. So just know when we say linear function, how it is represented. So given that m is 3, then c is 4, then the function becomes y is equal to 3x plus 4. That is when x increases by 1 unit. When x increases by 1 unit, y increases by 3 units. We are saying that when you talk about function, typical example of function is y is a function of x. Y is equal to f into bracket x. That's y is a function of x. That is how we write it. It means y depends on x according to the specific rule. Therefore, when you want to represent this in a linear function, it becomes y is equal to the slope, then times x plus c. So assuming that we represent m by 3, they represent the c by 4. We say that y is equal to 3x plus 4. So in its interpretation, we can say that when x increases by 1 unit, y increases by 3 units. That is, constant rate of change produces a straight line. So the slope is the 3, then the 4 is the intercept. So it means that when X increases by 1 unit, Y increases by 3 units. Any questions so far? Any question?
Hello, sir.
Ni.
Sir, please, when you say the intercept, is it the point whereby two lines meet? Because we are talking about linear. So if you say intercept, does it mean we will have two lines whereby their intersection could be the intercept? Is that what it means?
Just appreciate, read whatever is on the board, and let's see. You appreciate it.
Okay. So is that what you read?
Yeah.
Okay, a function describes a consistent relationship between variables if each value of one variable produces a unique value of another, then one variable is a function of the other. General form, y equals f into bracket x. Y equals f to the bracket x. This means y depends on x according to a specific rule. Linear function.
Yes.
A linear function represents a straight line
So
relationship.
it's okay. It's okay.
Okay.
So we are saying that. So in a normal English language, when we say intercept, what comes into your mind? Intercept. We are dealing with two lines. We are saying Y axis, X axis. You are saying that it intercept.
Okay.
What
That
comes
means
in?
a point they meet.
Uh-huh.
A point at which they meet.
Yes. So it's a line where the X and the Y axis crosses each other. That's the intercept.
Okay. Okay. So thank you. I get it.
You're welcome. But don't be Ade Eunice, do you understand whatever we are doing here?
Sir,
Are you sure?
I'm here. I'm following. I'm sure maybe if we start solving questions, I'll get more understanding to everything.
Okay. Bismarck. Bismarck Oman.
Yes, sir.
Okay. Steven.
Yes, sir.
Okay.
We are here with you.
Emmanuel there, huh? Do you have any question?
I said just, I mean, a concern, and also if you assist us with this, because it's a baby department as we joined the library, they mentioned. So not all the books that we are, I mean, the referencing books that we are able to get it from the library. And also, in this context, how our questions going to be set so that at least we will know how we will, prepare whilst we are learning, because a lot of us don't have.
Yeah. I learned I've uploaded some books on the system.
I
Today,
checked today, but I didn't see anything. I
yes,
started.
today I'll upload about 3 or 4 books there.
Okay, and say if possible, how format of how questions will be asked and how it will be answered, so that we, whilst we are learning, we will know how to prepare ourselves, ahead of time.
Okay. I'm saying that these are all tools used in economics. So these tools will be applied when we are dealing with proper economics. So this is just some mathematical tools which will be applicable when you move further into economics concepts. So just know how they are being calculated, so that when we move to demand, when we ask you to calculate for the slope of the demand curve, you'll be able to do it. When we ask you to determine the intercept of the demand curves, you should be able to do it. So you just know how they are being calculated. So when we talk about the slope, you know the formula to calculate the slope. That's what I want you to appreciate in this class. So slope and intercept explained. In the equation, I said y is equal to mx plus c. And we are saying that y is a function of the x. Therefore, m represents the rate of change. Then the c represents the value of y when x equals 0. Do you get it? I'm saying that the c, which is the intercept, is the value of y when x is equal to 0. When we represent x as 0, now we know that m is 3. C is 4. So when we represent x as 0, what will y be? So we are saying that the intercept shows where the line crosses the x-axis. That is, when C represents the value of y, that is when x equal to 0. That's what is known as the intercept. So it shows where the line crosses the x-axis. In deriving the linear equation, it is possible to derive the equation of a linear function given a certain vital information about it. Such information could be 2 points through which it runs a slope and a point. So with this case, we will restrict ourselves to the former case when 2 points are provided and the formula below is used to derive the equation of what? The linear function. So assuming 2 points are known, the equation of a straight line can be derived using this. Get this. I can give you this as a linear function. Then I can ask you questions on it. And also, I can give you the coordinates for you to derive the function as this. So when I give you a coordinate 2 points, for you to get me the function of the straight line or the equation of the straight line, this is the formula you use to determine the function of the straight line. And with this function, the change in y2 minus y1 over the change in s2 minus s1 will give you the slope. So to determine the function of this, the equation of the straight line, this is the formula. That is y2 minus y1 over s2 minus s1 multiplied by s2 minus s1. So this formula uses the slope between the 2 points. So let's assume that we have the 2 points. You have the coordinate. So from the equation of the line passes through the 5 and -6. Then the coordinates of 3 and -2. These are the coordinates. 5 and -6. And 3 and -2. So then we need to substitute these coordinates into the formula. And this is the formula. So y2 minus y1 minus y1, y2 minus y1 is equal to y2 minus y1. So this is the y2, -6, then minus y. Then you have the x2 minus y2 minus y1. This is the y2, this is the y1. So -2 minus 6. Then s2 minus s1, that's 3 minus 5 times x minus what? The initial x. So finally, s minus 2 minus 6 will give you what? Minus 2 minus 6 will give you what?
So that will be
4.
4. Yes, sir, 4.
Then 2 minus 5 is what?
2 minus 5 is 3.
Yes. So 4 minus 3 times x minus 5. You do cross multiplication. Then the final answer becomes minus 2x plus 4. Bismarck.
Yes, sir, please, can you go over the worked example again?
Okay. We have this formula. This is where we will use to determine the line, the straight line. And they've given us these coordinates. 5 minus x. 5 is the first x. Then minus x is the first y. Then this 3 is the second x, and minus 2 is the second y. So we have to substitute them into the equation. So when we substitute, we have y minus 6, that's the first y, is equal to minus 2, this is the second y, minus 6, that's the first y, over 3, that's the second x minus the first y, no, minus the first x, multiplied by x minus 5. Therefore, minus 2 minus 6 will give you 4. Then over 3 times 4 minus 5. Then you will get y is equal to minus 2x plus 4.
Hello, sir.
Yeah.
Please, from x minus 5.
So
And
just wait. So y from this side, y minus 6 will be what?
Y minus 6, that will be 6.
Y plus 6.
Yes.
Y plus 6 is equal to minus 2 plus 6. Okay, I'm coming. So y, it will be y plus 6 is equal to minus 2 minus 6 will give you minus 2 plus 6
Tara, go and sit down. Go
Sir,
and sit
please, I
down.
can't see it.
I'm coming. So this is what, then if in its simplest form, you get y plus 6 is equal to is equal to 4 minus 2. Are we seeing it?
Yes, sir.
So when we do cross multiplication, this is multiplying this. When we do cross multiplication, you just appreciate when we meet face to face, I will let us go over.
But I said, please, the face-to-face, some of us, we cannot make it because we are in the diaspora. We are not in Ghana. So
Don't worry.
if you can do something to
yes,
help
I
us
will.
also.
Okay. Eunice.
Hello, sir.
Yeah.
Please, what formula are we using to solve the question? Please, can you go back again for me? The formula is y2 minus y1
Yeah.
equals y2 minus y1 all over x2 minus x1. So, say, go back again. Hey, go for it. To the question, So if we are using the formula y2 minus y1, so why is it that there is no figure here? Here is y1, and here is y, instead of there's supposed to be a figure here. Y2 minus y1. So I don't know if you are getting me.
Yes, I get you. Okay, let me make it simple for you. Okay. Is that okay for you?
Yes, sir, it's now clear. Thank you. Thank you, sir. It's clear now.
Okay. So when we do cross multiplication, the final answer will give you y is equal to minus 2x plus 4. Can we go on?
Sir,
Yeah.
so from the formula that has been given, I mean the previous one, I mean the one that you just make it easier for us. How are you going to substitute? How are you going to know that this 5 dash 5 minus 6
Good. Now this is the
for
formula.
x2 or y1 or y2? How are you going to do that?
Okay.
How are you going to know?
Okay. So The question will give you the coordinates. So these are the coordinates.
Okay. All right.
When you see value like this or values like this, it means the first value is X and the second value is Y.
Y. Oh, okay.
So with this is X1, this is Y1. With this is X2, this is Y2.
Okay. All right.
Bismarck.
Please, the question.
Okay.
Can you go back to the question?
Go ahead.
To the worked example, please.
I'm coming.
The Y plus 6 equals 4 over negative 2. And then the last one, before the final result. What are we cross multiplying? I want to know what we are cross multiplying.
So when you have with this, so Y plus 6 is equal to 4 over minus 2 times this. So Y, any number, when you see a function from X, no, function from the left to that of with an equation, and it's a fraction. Then what to calculate is a matter of what? Cross multiplication. But with this, because they are not with the same base, you can shift the 6 to this side.
No, sir.
Uh-huh.
Sir, please, I think what Bismarck is saying is that you see Y plus 6 is equal to 4 over negative 2. Then
So,
we have times
so
X minus
4 over negative 2 is what?
So sir, are we cross multiplying the 2?
No. Listen. Let me make it simple for you. 4 over negative 2 is what?
4 over negative 2 will give you negative 2.
Will be negative 2.
Yes.
So negative 2. So negative 2 times X minus 5 will give you what?
Okay, so negative 2. So we'll get negative 2x plus 10.
Minus.
Hey, we'll get negative 2x minus 10.
Yes. So when we get negative 2x minus 10, then Y plus 6 is equal to negative 2x minus 10. When we shift the 6 to the other side.
Okay. Okay, so we group like terms over there.
Yes. I'm coming. Let me. So now Y plus 6 is equal to minus 2 because 4 over negative 2 will give you minus 2. X
Yes, sir.
minus 5. I hope it's clear now. So grouping like terms, Y is equal to minus 2x minus 10 plus 6.
So I thought negative times negative will give you positive.
Sir,
Yeah.
sir, please. I thought when a positive number crosses the equal sign, it becomes negative. Or
Therefore, it becomes what? 2x minus what? 16, right?
Yes, sir. Yes, sir.
yes, sir.
Okay.
Negative 2x plus 16.
Yes. So if we give you the equation of the straight line, so this is the formula. That's y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. And they give you the coordinates. So these are the coordinates. 5, negative 6, then 3, negative 2. And we are to substitute these coordinates into the equation because we know that y minus y1 is equal to y2 minus y1. You know that y2 is negative 2, then y1 is negative 6. The negative 2 minus 6 will give us what? 4. Then s1 minus s2, 3 minus 5 gives us negative 2. Multiplied by x minus 5. Therefore, y plus 6 is equal to minus 2 plus 6 into bracket all over 3 minus 5 multiplied by x minus 5. Therefore, we have y plus 6 is equal to 4 over negative 2 multiplied by x minus 5. Therefore, 4 over negative 2 gives you negative 2 because negative 2 goes into 4.
Minus 2.
Then the final answer becomes y minus x2 minus 2x plus 10 plus 6. No, it's 10 minus 6.
So it should be minus 6.
It's minus 6.
Yes.
It's minus
10
6.
minus 6. Because when positive crosses the equal sign, it becomes negative.
Didn't hear.
Huh?
The lady alluded to that, but I think you didn't get that.
Okay. So 10 minus 6 gives us what? 4.
4.
Yeah.
That's it.
So when they give you the coordinate and you have the formula, just know the formula, then you're able to substitute the coordinate into the formula. Therefore, you get the equation of the line. So this equation describes the relationship between x and y. So I've given you some of the coordinates. So find the equation of the straight line passing through these coordinates. 1 and 3, 2 and negative 2, 7 and 4, then 10 and 2, 7 and 4, then 10 and negative 2. So these are the coordinates. Then you have to find the equation of the straight line. I hope you can do it.
Yes, sir.
Yes, sir. Please put the formula there for us.
So I want each and everyone to practice this one.
Hello, sir.
Yeah, Andrew.
Please, I have a question. Let's go back to y plus 6 is equal to 4, bracket open 4, bracket close out of minus 2, multiplying the x minus 5. So in this case, we are getting the 2 to be able to divide the 4. So let's say we are having a denominator of 3 there. How are we going to solve it? Because I am thinking with this equation.
You have denominator 3 there.
No, I am asking a question. I mean, let's say there was, because we are having 2 here, that is why the 2 is able to divide the 4.
So if you get 1.5, it's okay. You can get a fraction, but it should be in a decimal. Do you get it?
No, I'm not really getting it well.
You are saying that assuming instead of 2, it's rather 3.
Yes.
So 4 divided by 3 is what?
This a minute, let me check. Four divided by 3. 1.3333.
Yes. So you can get a decimal figure there. Because you know that in economics, we deal with figures. So you can get the nearest whole number. So 3.33. So you can just write 3.3.
Oh, okay.
Do you get it now?
Yes, yes.
So these are some of the practical questions you need to try your hands on. All the questions I've been giving you is the same questions that will be coming in the exams. Similar questions will be coming in the exams. I will not deviate, I will not divert from any, I will just stick to the questions at each of the the lectures that I've been teaching. Eunice.
Sir, please, the x minus 5, is it multiplying both or is only multiplying the numerator?
It's multiplying both, but if you're able to divide it.
Okay.
So what if you are not able to divide? That's the question.
So I'm saying that because we want a straight line, an equation. So if you still multiply, you still go back to factorize it again. So when you get it this way, it's a matter of just factorizing it. So assuming.
Because I was trying something here. If you have to factorize the 4 over negative multiplying, can you please go for it? The 4 over negative 2 multiplying x minus 5. The numerator, which is the 4, is going to multiply through the bracket for it to have a denominator of negative.
So you go back. So it's a matter of just dividing this side by this side to get the slope. Just get this in mind. I said this side gives us the slope. So when you reach here, don't multiply. Just get the slope. Are you with me? I'm saying that with this formula, the y2 minus y1 over the s2 minus x1 gives us the slope. So immediately you get this side. It's a matter of dividing it to get the slope, the figure there. Don't cross multiply because you go back. So just get the slope over here, get the figure here, divide it to get the figure there before you continue with others. So that's why we got the figure to be -2 here. So this is the slope. It's negative slope. Is that okay? I'm saying that with the formula, whenever you substitute the coordinates into the formula, first of all, you need to determine the slope. So, and then figure you get here, make sure you divide it to get the figure there. That represents the slope. So when you get the slope there, then you continue with the others. That's why after getting this, we got this side before continuing with. Is that okay?
Hello, sir. Yes,
Yeah.
sir. Sir. Sir, please, assuming the question, you have like maybe -5 over 2. And then into bracket the x minus, let's say, a number 1. So here the numerator, the denominator is 2. It means we'll get fraction there. Can I take it to the left side and multiply it to the x?
No, no, no,
by
no.
1 so that I'll have a linear.
No. No. Listen.
For instance, I'm doing the first question, the questions you've given.
I'm saying that any figure you get here, arrive at the final number, final value here to get the
Yes.
slope. So assuming it's 5/2. 5 divided by 2 is what?
5 divided by 2 will give you 2.5.
2.5. It's okay. It's a slope. The slope of the line is 2.5. Then you put this 2.5 here before you continue with the others.
Okay. Okay.
So first of all, you need to determine the slope before you can proceed to the other calculation.
Yes, sir.
For the first one,
Ima?
yeah.
Are you okay?
Yes, I say I'm on it. I'm on it. Thank you.
Welcome.
I think the thing is a bit confusing, especially the first one. But as time goes on, we'll practice. It will come on to be on.
Yes. You practice the questions I gave
Yeah.
you.
Thank you.
Hello, sir.
Yeah, Stephen.
So please, with regards to the question that Nima asked, can you please take us back to last week, maybe the calculation that you did? I think we still have like 15 minutes to end the lesson.
We are not done with the class. We want us to go to, we have other topics to be covered. You have about...
Yes, sir. Just a small clarity, because
A
for
flash.
the calculation, it was
No,
very,
I have class. I have topics to cover. Unless I'm done with the topic, I can't go back to the next week's last week's topics. Let me finish with this. If you have more time, then we'll go back to what we did last week. We will have several topics to cover. Is that okay?
Yes, sir, it's okay. But we were only requesting for just a summary, not maybe the entire note, just a summary, some key notes or something like that.
Summary of what?
So there was one question, yeah. It was one question that was very, very confusing. It's a bit complex, like this what we are doing right now.
What's the question?
It was into brackets 3x minus 7 all over 2. I mean, raised to the power 2. Bracket close, raised to the power 2.
Three x plus 7 raised to the power 2.
No, into bracket bracket open 3x minus 7. Bracket close,
you know what?
raised to the power 2.
No. You know what? Let's finish with this. When we get more time, we'll go over whatever we are done. Don't worry.
All right, sir. All right.
Because my duty is to make you understand all the topics I'm teaching you. So just relax. We will have some topics to cover. So when I'm done with it, have more time, then we will deal with any other issues that will come up.
All right, sir. All right.
The next on our topic is solution of what? Equations in one variable. Like how to solve linear equations. Now we know how to determine the linear equation. You know how to come up with the linear equation. You know how to find the equation of the straight line. So our next aspect is
got mail.
Sir,
yeah, Salome.
sir, please, I thought you asked for at least one of the answers to the questions you gave for self-assessment, so that we will know whether we are on the right path or not. That you didn't do anything at it.
Okay, type it at the chat session.
Yes, so somebody type his answer there, but you didn't do anything about it. So I don't know whether what I've gotten is right or not.
So you know what? Just it's a practical examples. So when you get to the house, follow the steps and practice. They are practical questions. So follow the steps and practice them. Because we have a lot to cover. So after this, then we have, if we have more time, ample time, then we can go back and deal with it. But I've seen that you are I've seen that you are confused already.
Yes, sir. Because so please we can tackle more topics, but we couldn't get the understanding that well. That wouldn't help us. Please, beg.
Okay, let's
And also say not everyone did economics in SHS, so someone new to.
no, this is not economics at the SHS. This is a
Yeah, yes,
this is
sir.
not economics at the SHS. Because
This
you never
is
meet
proper
that.
economics.
Okay, so let's get this. Okay, I want each and every one to start calculating this. The first one. So a Y1 so with this complete, one is what? The one is X1.
S1.
And 3 is Y1.
Y1.
Yeah.
So this 3 is also what? X2.
X2.
Then Y2. The negative 2 is Y2. So let's substitute it and let's see. I want each and every one to substitute it in the formula.
Hello there. Hello there.
Yeah.
Say.
Will you y minus 2?
No, please. You are confusing us. You have to look for the M first.
You have to look for what?
The M, so the Y2 minus Y1 over the X2 minus the X before you come and do the.
Before, yes.
So say after keep quiet. The Y2 minus Y1 X2 minus X1, you get -5/2. which will be negative 2.5.
But it's the same, sir, it's the same
Before
thing I was
then, before you proceed to, you come and use you find the point slope.
No, please
Yeah.
relax for us. I beg you, relax for us. Let's go slow. Okay.
So with the formula, let's substitute them.
Yes.
So y, it will be y minus what?
Y minus 2.
Y minus 3.
Why are you confused?
It's y minus y1.
I'm coming, my miss. I'm coming. So now the coordinates are 1, 3, 3 minus 2. So let's put them in the formula. So y minus what?
3.
Y minus 3 is equal to 3 minus 2, right?
Negative 2.
3 minus 2.
You're getting confused.
You are getting confused. The equation is
Say.
I'm coming. Wait.
Oh, keep quiet.
Why am you mute your mic?
Say.
Yeah. I'm coming. I hope you got this.
So please, can you go back to the question again? Because
Hello, sir.
Yeah, I'm coming. So y minus y1, that's y minus 3 is equal to 3 minus 2, because the y2 is minus 2.
it's minus 3, yes, sir.
Yeah,
So you
so
get
So that will be minus 2 minus 3.
yeah,
it will be what?
Minus 2 minus 3, sir.
Minus 2
not
minus 3.
The minus 2 is the y2, sir.
Yeah. Minus 2 minus 3.
Yes, sir.
Okay. So minus 2 minus 3 over 3 minus 2, right?
Yes, sir.
Yes, sir. That's correct.
So minus 2 minus 3 will
over
give
3 over 3 minus 1.
is equal to minus 2 minus 3 is what?
That will be minus 5.
Minus 5 over 2, right?
Yes, sir.
Yes, right.
Bracket x minus 1.
Yes.
So minus 5 divided by 2 will give you
Negative 2.5.
negative 2.5, yes. So x minus 1 into bracket. Therefore, y minus 3 is equal to y is equal to
2.5 x.
Minus 2.5
2.5 x
plus 2.5.
plus 3. Wait, 2.5 again.
2.5. So the
minus 2.5
bracket
times minus 1.
The bracket is x minus 1. So when you multiply
2.5.
minus 2.5, yes.
So plus
When you multiply
2.5
yes, correct.
plus 3. So y is equal to minus 2.5 x plus 5.5.
Yes, sir.
Is that the answer?
Yes, sir. That's what I got,
Yes,
sir.
that's the answer.
Who didn't get that answer?
Go to minus 2.5 plus 5.5.
Yes. Who didn't get the answer?
Sir, please, the minus 3, we crossed it to the other side. The y minus 3 is equal to minus 2.5 into bracket x minus 1.
I'm coming. Let me type
Yes,
it.
it became a positive 3. So 3 plus 2.5 will give you 5.5.
So when this 3 crosses the equal sign, it becomes what? Positive.
Positive, yeah.
Yes, sir.
So y is equal to minus 2.5
plus 3 into bracket x minus 1.
So y is equal to minus 2.5 x.
Yeah, 2.5x, yes.
Plus 2.5 plus 3. I hope you all got this.
So you didn't bring the x to the minus 2.5.
Yeah, so y is equal to minus 2.5x. Yeah.
So the final answer is y is equal to minus
2.5x 5.5
plus 5.5.
Yes.
Yes, that's correct.
So when they ask you what is the slope of the line, so what is the slope?
When you ask
So the slope is 5.5.
The slope is the minus 2.5. And what is the intercept?
5.5.
Yes. Any question? So when they give you the coordinate and you substitute, make sure you find the slope first before you proceed to the other bracket. Then you do the factorization.
Yes, sir. Hello there.
Yeah.
Does it mean if I if I start working and immediately I take let's say y minus 3 minus 3, I cross it over to the left side, to the right side, so that my y will stand alone. So I will be able to work it. Can I go by that rule too?
You can go by that rule, but it will expand it in such a way that you might be confused.
Complex. Yeah, to be
Okay. Okay.
So just make sure that you first of all determine the slope first before you can proceed to the bracket.
Right. Yes, sir.
Any question? So you are to work on the other practical questions. I hope you can do it.
Yes, sir, we
can.
can.
Yes. It's time, right?
Yes, sir. We have just 4 minutes.
Yes, it's time.
Okay, so any questions so far?
Yeah, sir, please. So the next, maybe our next meeting, is it possible you can use the whiteboard so that you can
Yes.
start with the calculation, then we'll be following that. I think that one will be
Yes.
great.
Yeah, I will do that. I wanted to use it today, but it seems my laptop is freezing. I don't know what is wrong with that. So hopefully next week we'll be using the whiteboard in addition to any other tools to make things more easier for us. Don't worry, eh? My duty is to make you understand whatever I'm teaching you. So next week I'll apply all the other measures for us to get things done right.
Thank you, sir.
So let's call it a day. But make sure you practice the questions provided.
Given
Yes.
one.
So I will upload the slides on the LMS.
Together with the books also.
Yes, together with the books. I upload all the recommended books on the system so that you acquaint yourself with all the other topics. Okay, let's call it a day.
Thank you, sir. Have a nice day.
Thank you, sir. Have a nice day.
Oh, the same to you.
of x1,
No.
y1.